All right, we're in for a real treat next. This is always one of the highlights for me of Dev World. Josh here. Josh loves computer. Now, you might think, well, big deal, we all love... No, look. If you're going to tell me that you love computer, I'm going to say, all right, name 3. Josh really loves computer, and every Dev World, there's always something that is just mind-boggling about what they have managed to do with computer, including computers that in any other person's possession would be long, gathering dust in the attic, but Josh waves their magic wand and manages to make amazing things happen with them, and I think we're in for one of those little special moments today. So please join me in welcoming Josh to the stage.
Hello. I thought it'd be interesting this year to talk about things I've done for work, and for the last nearly 3 years I've worked for this company called Buildkite, who some of you use. And I thought it would also be interesting to talk about some software that some of you may have also used to or relied on to do CI or CD for your own work. So it is a bit different because I'm not going to get into user interface much at all. It's all about all sorts of other things that you just don't necessarily think about. So anyway, first a bit about me. That's all you really need to know. Here are some cat pictures. This is Myrtle. She's 5.5, going to be turning 6 early next year. There's a watermelon next to her for scale. As you can also see, she fits in a small DigiKey box. Here's some more photos. Yeah, she's a very incredibly photogenic cat. She's lovely and round. Yeah, there's some more. You sure? I've got more. The photo on the right is when she was sick and we had to take her to the vet. The vet gave her some drugs and she was the biggest eyes I've ever seen on a being. Hunting a bee. Yeah, so that's Myrtle. Thank you for admiring Myrtle. Now on to more serious matters. Buildkite. If you're not familiar with Buildkite, it's a company. It does several sort of developer-related things. Mostly known for pipelines, which is basically the CI/CD part of it. But there are a few other teams that I'd like to call out. Mobile Delivery Cloud, they do hosted CI runners, integrates with pipelines. Test Engine do things like test splitting, so you've got a lot of unit tests in your project. You want to run, you want to spread them across your runners or your agents. The test splitter can help you there. And they can also point out flaky tests over time. And there's also packages. So they host things like Debian packages, Red Hat packages. They're working on container images, that kind of thing. And so some of you might not be aware of what CI/CD is. It's basically remote code execution as a service, which is definitely one way to put it. Here I've put together a comparison table of RCE vulnerabilities and CI/CDs. Obviously, vulnerability is a big problem. You have to sneak your code into be run. It's not easy to debug. You really kind of spraying and praying that your vulnerability exploit works. Whereas in the CI/CD case, it's obviously a problem if it's not working. If you just want to run some code, you push it to your repo. You get convenient logs at the end. You can exfiltrate data really easily from a CI/CD pipeline. It should be really easy, right? So I think that this isn't official or anything, but I think that CI/CD should be, do your remote code execution deliberately and properly. And so what is the Buildkite Agent? This is the piece of software I'm going to be talking about. It is basically the official runner. First, you may be confused by the title. It has nothing to do with agentic AI. So sorry if you're ever expecting that. It is the job runner for Buildkite pipelines. And so it's open source. Obviously, we don't necessarily want you to have to trust us that the code is totes legit. You can go and poke at it yourself. It's written in Go, which might be a bit different for some of you, more in the Xcode sort of iOS, Swift, Objective-C land. Go is a bit different. And it's not just the runner, it also has various other subcommands for interacting with Buildkite during a job. But at its core, it's basically this one loop. Fetch a job, run the job. Fetch another job, run the job. How hard could it possibly be? Veering into the philosophical, we have what is a job anyway? I guess it's a command that you run? I don't know. How long should that loop run for? Should it continue forever, or should it quit and then you spin up another one in a new ephemeral environment? How long should the job run itself? Should it have a timeout? How frequently should that loop be running? Should it be pinging once every second, once every 10 seconds? That's more of an us problem, because if it pings too frequently, then you start DOSing us. How should it verify a job? How does it know that a job has come from your pipeline and not from evil attacker? And all the other things it does, like cloning code and running hooks and inserting timestamps and setting all these other lovely things and blah, 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 blah. Yeah, it's got to do a lot. And it's written in Go. So the reason why it's written in Go is basically because of the same reason why Buildkite even exists. And that reason is Keith Pitt. He's the founder of Buildkite. It was his birthday yesterday. I'm not sure how old he is, but yeah. He launched Buildkite on his birthday. He's apparently launched something else yesterday. I don't know what it is, because Buildkite and Keith parted ways about 9 months ago. But we can all admire some of the first commits Keith made on the agent repo. Grab and builds, some restructure. Who hasn't been here? I love the honesty of this. But it does make digging into the code a little bit frustrating when you're like, why did he do that? I joined Buildkite at that point, sort of towards the right of the slide, October 2022. So that code's been sitting around for quite a while. And one of the problems with old code is that you don't necessarily know what bits of it you can pull out and rewrite or get rid of, because it's old and crusty or full of bugs. Another way of looking at it is that that age is a benefit. Like, there's all that accumulated knowledge in the code base of what customers, the kind of thing users want to be able to do. It's put by Titus Winters in the software engineering book. Software engineering is programming integrated over time, and I think that's a really good way of looking at it. But the corollary of both of these, I think, is that old software tends to be full of things you don't know you shouldn't remove. The other reason why we have been using Go ever since 2014 is it's easy to cross-compile. We've got 21 different combinations of operating systems and architectures that it gets released for. Go supports several more. But do we have a fleet of random Linux RISC-V chips or PowerPC 64 little endian chips or MIPS? No, we don't. In fact, I think it's fair to say we don't actually properly test most of those at all. We're more or less relying on the fact that Go has good unit testing for its own releases and what it promises that it supports in its release notes. We do, however, use the product to do unit integration tests on Linux, and Windows. By Linux and Linux, that's not a typo. We have the ARM builders and the AMD 64 builders on AWS. And similarly, we've got some Windows. And on the topic of Windows, Windows is always the painful one, just because of the way it does things differently. Like a blank Windows install doesn't have tools we take for granted elsewhere. Like even a Mac still has Bash, or it's really, really easy to get. It's easy to get Git installed on a Mac. On Linux, it's not so easy to get on Windows. You have to download something and install it and this and that and the other. Actually, the path separator is a backslash rather than a forward slash. They look like that. Windows figures out whether something's executable or not based on its name rather than some permission bits and so on and so forth. And Go on Windows is simultaneously great and terrible because there are good packages and good standard library support for several of the things that you need to do in Windows. But also, it's just different enough that you have to know where the missing stairs are. And for that reason, we've done most of our development on Macs, but the best platform we've got currently is honestly the Linux-based ones. But even Linux has its own foibles. A while ago, I was digging into this problem where sometimes the agent would fail with this message, ETXTBSY. And I'd honestly never seen it before. And it was accompanied by this string, text file is busy. What the hell does that mean? Well, it turns out text file is what old Unix refers to the program, the executable code in a program is called the text section. And that nomenclature exists today. And busy is referring to the fact that the file is open for writing. So translating it into something a bit more humane, you're trying to exec a file that is still open for writing. And I went through the code, and I went through the code, and I went through it again, and I could just not see where we were holding the file open. We had clearly closed all the files that were meant to be written in order to execute them. Because what it does, which I'll explain in a minute, it needs to do that. So the bug, it turns out, is kind of subtle. When you create a subprocess on a Unix-like environment, first you fork, which creates the new process, but it's still effectively kind of like a clone of your existing process. And then you exec the new program into it. So it's a two-step process. So here we have a parent process Q, and it's creating a subprocess Q, parent process P, subprocess Q, fork, exec, and so on and so forth. But the subtlety is that when you fork, the operating system copies the open file descriptors, the references to files that it has open. And then the ones that you marked specifically to be closed later on, or when a new process is started, get closed on the exec step. So there's a small window of time where the child process Q has the file open that you might have had open in P. And that's sensible if you're operating in like a single-threaded environment, because you're never going to be able to like simultaneously have a file that you're written and closed, and then. But it turns out that this is what was happening. Was what had written a script. We had simultaneously forked a new subprocess. In the meantime, and then we closed it. We closed the script that we'd just written. But at that point, the file descriptor is still accessible by the new child process. This is a long-standing Go bug that the standard library just doesn't support this, particularly on Linux. Other Unix-like platforms like macOS, the BSDs, for instance, have other ways of dealing with this. Like there's an option called clove fork, which is basically where the file descriptor gets closed at the first step, which sounds very logical. But Linux doesn't support this. They were going to remove the etextbusy error code, and then they put it back. They were going to add a clove fork-like flag, and then they didn't put that in. So no one knows what's going to do. They're going to do. But why do we need to write scripts on the fly anyway? That sounds a bit weird. And the answer is environment variables. Because I think it was Keith, but someone had the brilliant idea of letting the agent support hooks, so you can have a pre-checkout hook that runs before your code is checked out, and a pre-command hook that's run when your command is about to be run, and a post-command hook, and so on and so forth. And the idea was it'd be great if the environment variables passed through all the hooks, so you could read in one hook and write a new environment variable, and it would be picked up by the later hooks, or in the command. But this is a bit difficult to achieve, because what you have to do with environment variables is environment variables by default are local to the process that creates them. And they're only inherited by subprocesses. We don't want to have all the hooks be subprocesses of each other. We just want to execute them separately. So what we have is this shell wrapper, and I'm going to get rid of the Go templating there for you. So this is what it more or less translates into. We dump the environment before we run the hook. We source the hook into this environment, which lets it preserve, it's treated as the same process. So it gets all the environment variables that would be set by the hook. And then it captures the environment variables after. And this hack was, I think that hack was invented by Keith, and it works fairly well. So that's why we're even bothering. Now I'd like to talk about logs. we have logs. So what happens when your command is run is that the things that it writes, that it would write to the terminal, it has to be captured. And we want to display that to you in your, when you go looking at the job. So actually, if I could probably show you. Let's start the agent. There we go. So the agent's obviously talking to my terminal here directly. But when we run a job, let's make a new build. This just says, the actual terminal just says it's picked up a job, it's run the job, it's finished the job. The actual output from that job was captured by the agent and then packaged up and sent to us. And let me just blow that up. There we go. So there's the command that I would have run in this, this pipeline, and the logs were captured and sent to us. So they're not displayed in your terminal, they're displayed on the Buildkite website. And that's more or less how it works. Basically, the Unix file streams basically gets read periodically and then uploaded as chunks to the API. Now, how complicated could that be? Well, here I started at Buildkite like almost 3 years ago, and one of the first things I read was this piece of code. And I'm not even going to explain it, but the basic idea is that it takes the stream of log that has been written from your command and turns it into chunks and then puts those chunks on a queue. And I didn't have to get very far in this code to see a potential problem with this. It takes the full process output, which kind of implies something, and it was easy to confirm by reading the code. It buffered all the output ever written by the command. And that command could run for a really long time and output a lot of output. So what happened? I fixed it. I fixed it is what happened. I made it so that the logs were, there was no longer a buffer holding all the logs for a command. It just, once it was done uploading a chunk, it would get rid of it. And then it would make a new chunk and then get rid of that. Fixing this bug caused my colleagues to be paged. And the issue there was that, well, back in the old regime where it would buffer all the logs, eventually the log buffer would fill up memory. The process would crash. Or, you know, if you're on Linux, then it would be the killer would start killing processes until it had memory again. Crashing prevents from the logs being uploaded from continuing to be uploaded, right? The job's over. And with my fix, the logs could be uploaded forever, which meant that the problem was shifted from the client side to the server side. The next thing I want to talk about is, anyway, we fixed that, that's fine. The next thing I want to talk about is redacting logs, because it would be awkward if, you know, we captured this log output and we stored it in our logs, because now we have your private key right there, and all someone has to do is go have a look at your logs, and then they could hack your system, and that would be crap. Actually, yeah, so we want to get rid of that part. We want to make it look like that. But obviously, there's a lot of ways we could do that and not be 100% like coverage. Like here's my totally super secret ROT13 encoded OpenSSH key. That would unfortunately pass through. There's very little we can do about like, or well, let's fix ROT13. So okay, I'll do ROT12 or ROT14 or you know some other trivial transform. There are too many ways to re-encode a piece of information that you could bypass a secret scanner. But we do have some redaction built into the agent. So we have to first philosophically decide what a secret is. And well, they're usually in an environment variable, I guess. We don't want to bother with things that are too short. That's just an efficiency hack, I guess. It could go across multiple lines like the SSH key, or it could just be a single small blob. Those line breaks could have fairly arbitrary white space in them as well. Like maybe the key's been indented, or maybe you've looking at some baked text output versus some unbaked. Obviously, it's got to operate in a streaming fashion, just like the log chunker. It's got to be able to it's got to be able to not sort of stutter, because now the whole log isn't being buffered. It can't just scan the whole thing at once. It has to go bit by bit. The biggest takeaway from rewriting our log redactor was that coverage-guided fuzzing is a really good thing. So here's a unit test that might exist in Go. And it will look a little bit different to other unit tests that some of you may have written. But the basic idea is always going to be the same. Is here's some input, we call a function, we compare it to some output that we want, and if the output doesn't match, we fail the test. Right. Here's a slight variation on that function, where we've put the input and the desired output next to one another in a table, basically just an array of structures. And then that means we can very trivially add more cases later on. We just add them to the table. And then so there's the table, and here's a loop over those tests that would execute them one by one. And we can make those parallel, and we can do all sorts of other things. But the real shift with coverage-guided fuzzing is that you can write a test like this, where you say, here's my function, and it's going to go in the closure there. Come up with inputs for me that try to crash this or try to make it fail. And what it does is it starts with the initial cases that you added, and then it mutates them a bit. It adds a character on the end, or takes a character off the end, or increases a number or decreases a number, or it has a bunch of like little things that it tries randomly. Think of like a big random parallel search. And when it looks at the coverage of your code that the test that it just ran had, so like which lines did it hit, which lines did it not hit, and if there's a change in the lines that it hit, it goes, aha, I've learned something new about the program. I'm going to create some more cases like that. This approach uncovered a few interesting cases in the agents. No, not that one. In the secret redactor. So if I go to, I should be able to run this here actually. Go test fuzz. It became. It went from a secret redactor to a string replacer. So it's going to be a fuzz replacer in the internal replacer package. And it immediately found one that is currently broken. There was a fix to how white space was handled, and now if your secret is a single space, and it doesn't get redacted properly. So that's one to be fixed. Short anvil break. Thank you. That was drawn by me. I didn't need a. I didn't need a Mid-Journey or something. Thank you. A third thing that we worked on for the agent over the past couple of years was signing and verifying. This is addressing the concern that, okay, so you've written a pipeline of commands that you want to run on your hardware that you're running, your jobs on. Don't run commands that someone else has defined, like a hacker. But that now includes us, Buildkite. And this concern is, if you're paranoid, I guess you might want this. Some people use it. Previously, there was a tool which was a collaboration with Seek, basically did a version of this kind of signing and verifying step. We wanted to build it into the tools that we offer. So you wouldn't have to download something separately. But to talk about signing and verifying, I need to first talk about YAML. YAML is why YAML? The same reason that anything in this talk more or less exists is basically Keith Pitt. But it was the direction that everything was going, like when infrastructure as code was kind of coming around 12 years ago. YAML was a popular choice. Here's some typical looking Buildkite YAML. In fact, I stole this from the agent's own pipeline. You have objects with keys in them, and you can also have lists denoted by a little dash. So here we have a steps object. It's got a list of steps. The first step has a name, it has a key, it has a command, and so on and so forth. Is it just fancy JSON? That's the way most people seem to use it. But I'm going to get everyone in the mood for a quiz. So, are these two YAML documents equivalent? Who can tell me? I'll give you some information. The ampersand plugins is a anchor, and the star plugins is an alias to that anchor. So basically, that copy and pastes a section of YAML from one place to another. And the answer is actually, no, these documents aren't equivalent because the X anchors part is not present on the right side. But they were equivalent by Buildkite pipelines. And similarly, here's another question for you. Are these equivalent? And to help you figure that out, I should point out that the double chevron there is called a merge key. And that lets you, it's similar to an anchor and an alias, but what it does is it basically copies the contents of the thing into a new mapping. And the answer is, again, no. See, on the left, we've got just plain objects, and on the right, we've got lists of objects, so they're not quite the same. Obviously, YAML can be a bit of a pain for subtle bugs like that to sneak in. So anchors, aliases, and merges. We have some typical unmarshalling code in Go. It kind of looks like this. You set up a struct. You tag your fields with little YAML tags. Little tag strings like that. And that basically tells the YAML package where it's going to stick the value as it unmarshals that input. So basically, the family is going to go in the family, species is going to go into the species field, and so on and so forth. Anyway, so for Buildkite pipeline, we explicitly support those three things that I mentioned a couple of slides ago. It could have a top-level steps object, or it could just be a list of steps. It's still accepted. Okay, we can handle that. We can override the unmarshalling for the pipeline. Command can be a string or a list of strings. I guess we can do the same thing for that. Plugin's going to be a list or a single mapping. But the orders of the keys matters. And one important detail to all this is that we want to be able to preserve functionality going forward. So if you want to write a new pipeline YAML, an old version of the agent should be able to upload it, and it should just still work. And the situation with Go and YAML parsing is a bit complicated now because back in April, the main package everyone was using became deprecated. There was a fork by the YAML org itself that got sprung up. Meanwhile, there was also another package. Anyway, no points for anyone who guesses which one we're still using. The key point, though, is that none of them support order-preserving maps. They all assume that the mappings in a YAML document are not, well, the order is not important, is what they assume. So when we did, before I even talk about the next thing, we have two separate implementations of the parser, of course. You can upload your pipeline using the user interface, and that's read by the Ruby monolith, or the Rails monolith that is Buildkite. Or you can go via the agent, where you have some pipeline.yaml in your repo, the agent reads it, and then uploads it as part of what it does. So we have two different implementations of the parser. And we need the order to be preserved because plugins should run in the same order, and we don't want to be able to. We really don't want to break people's pipelines. If we implemented a change where the order bit now became random order or whatever, there's a real risk that someone would have a plugin that implements one set of environment variables that are read by the next one, and upsetting that order could break someone. So we care about that a lot. So we ended up implementing a whole heap of code to specifically implement ordered maps by default in the plugin parser, in the pipeline parser. This became a three-step process where we would use the YAML package to unmarshal into its own temporary YAML node structure, which preserves all the detail about the pipeline YAML, decode that into an ordered structure, and then unmarshal from that into our destination structure. So now I've described some of the chaos involved in YAML parsing, we need to talk about what a job is. What is a job? Well, from the agent's perspective, a job is basically a list of environment variables. These are produced by the backend based on the pipeline that you feed it. So here's some corresponding environment variables to that pipeline step I showed you before. There's the command, runs the script. Where's the repo? It's this repo, and so on and so forth. Which means that the data can flow this way or that way, and then once it's gone into Buildkite, it comes back to the agent in the form of environment variables. So we have one form and it turns into another form. How the hell are we going to validate any of that? And which parts are important? Well, the command is important. Okay, the command is important, and that could be a list of multiple commands. So the command and the plugins are important, right? Yes, of course, because the plugins are downloaded when the job is run, and they have scripts in them, and it's obviously important that we don't let a hacker run random plugins. Okay, so the commands and the plugins and the envars that are defined in the pipeline are important. Okay, what else? That's all that's important. No, the repository URL is important. Because we don't want you to just download, we don't want the agent to download some random repo from GitHub. But that information is not in the pipeline at all. That's set in the user interface. The matrix steps. Okay. Here's how we build 21 different combinations of operating system and architecture. We have a matrix. Build matrix lets you split one step into multiple steps, which are combinations. And each combination gets its values filled into a template. So here, the name and the command. So we have these values. We have two different variables, OS and Arch, and then they get filled. They can be adjusted. We can turn them individually on and off if we need to. So we no longer build really old Intel binaries for Mac. We specifically add Dragonfly BST, that kind of thing. And then those values get filled in multiple combinations into things like the name and the command. So we need to sign all of that. And then it gets transformed into JSON and uploaded. But then there's another problem. It's like, which JSON should we sign? Are these things equivalent? Well, they are according to a JSON parser, but not if you're signing a blob of data, because the one on the left has white space in it, and the one on the right, well, so we needed a way of normalizing JSON down to a known quantity, something that wouldn't change if you reordered the fields or if you wanted to represent your numbers differently. So we used a thing called JCS, which is an internet RFC that someone submitted, basically turns it into one of these canonicalized things. A third thing I wanted to talk about, because I know that some of you may have come across Ruby on Rails. I certainly hadn't really played with it at all before Buildkite. I still honestly haven't. But I find that some of my colleagues really want to know how to contribute to the agent as well, because they care about it. And the biggest question that they always have is, how do we organize our code? Here's what Rails create generates for you today. It gives you an app folder and a bin directory and a config directory and a DB and all these other bits and pieces. And I look at that and go, wow, that's a lot of stuff you get for free. And the Go world, you run Go mod in it and you get the top two files, or the top file even, and then you're left to figure out where you put your code a bit. There is some documentation and recommendations people have, and opinions people have on the internet, but it's completely black and white to the Rails world where the suggested structure is given to you for free. Here it's, well, figure it out. Another particular difference is where you put your unit tests. In the Rails world, there's like a spec or a tests folder, and they're kept separately to the code that's being tested. Whereas in the Go world, typically you put your tests in the same package as the code you're testing. So foo test would test the foo kind of thing. And the specs themselves, the RSpec approach is very much, let's make some fixtures, let's set up a context. In the context, we're going to describe in plain text what the thing's going to be testing, and then using some assert-like language, like we expect X to be Y. In the Go world, it is still a bit more Wild West. But what happened is at Google, there's a team who do what's called readability reviews, and for a while they weren't sure like what they wanted the code to look like exactly, but eventually settled on a style that kind of looks like on the right, where you have got and want instead of actual and expected, and preferring to avoid assert libraries. So instead of saying assert x equals y, actually just writing if got not equal want. The consequence, one of the reasons for this is in Ruby, which is effectively an interpreted language, the VM can basically reach into the code and say, hey, here's the line and the surrounding context that failed. Whereas in the Go world, which is compiled, the error failure doesn't necessarily know the best information to tell you what function call didn't produce the expected result. So you have to kind of add that yourself. And if you use an assert library for that, the assert library is going to say, well, values x and y weren't equal, but doesn't necessarily tell you where those values came from. So now the part you've all been waiting for. What is the oldest Mac you can run a Buildkite job on? Well, presently, I think we use Go 1.24, and the oldest Mac OS we support that would support would be Big Sur, which is Mac OS 11, and that runs on I think that can be run on as low as a 2013 MacBook Pro or MacBook Air, which is kind of, okay, 12 years, that's a fair way. But I think I can beat this by another 15. I'm going to use a piece of technology called Retro 68. This is a port of the GCC compiler to target the M68K and the PowerPC chips used in much earlier Macs. And I'm going to do it like this. So under my jacket here, I have my PowerBook G3, which I'm now going to boot up. Feel free to come and have a look. So you probably didn't hear the startup chime. It's going to take a minute to start. Anyway, and the idea is that I'm going to run a hacked up version of Buildkite Agent. It's not actually Buildkite Agent. It's like 600 lines of terrible, terrible C++ that I didn't vibe code it, but I did struggle myself to get it written. So anyway, please work. It'd suck if I brought you all this way and it didn't work. I think it's booting. Come on, yes, macOS 9.2. Okay. I didn't bring anything older because I wanted to be able to take this in my backpack on the plane. I'm getting increasingly touchy about my old Macs. As they get older, I don't want them to break. Feel free to come up and have a look. We're basically in afternoon tea time now anyway. So yeah, it's going to talk over this yellow Ethernet cable to my M4 here. And this is running a SSL stripping proxy called Web1. Which is popular for use with retro applications. It's if you've there's a Mastodon client called Maxtodon written in MacPython that uses. I think you need to use something like Web1. So let's try and get this going. Is it booted up yet? Oh, it's almost there. I'm going to use real VNC. But unfortunately, we have to wait for VNC to boot up on this thing. And I'll know in a second, because Macs of this era aren't like console-based machines. They're all GUI. So if you want to run a server, it generally has a window associated with it. So you have to open it up. OK, I'm in. Network time error. The reason is because this thing doesn't have a battery in it. The battery that came with it died many years ago. So it has no idea what the time is. That's fine. OK, so we're in. And I want to blow that up. Oh, is that? Yeah, there we go. So now you can see it there. OK, we're going to hide VNC. And now we're going to run. All right, I think it's on. Let's run. Oh, I did kill this one, didn't I? Yes, okay, cool. Let's run that. Yes! And there's the resulting log, even with a functioning timestamp. It says the timestamp's in 2040, because again, the clock is wrong, but. So yep, that was the demo, and that's it. Thank you. Special shout outs to Myrtle, to my partner Hannah, to previous and past and present agent wranglers, to the Bickies in support. Bickies is what we call Buildkite employees. I'd also like to shout out the creators of Retro68, the Mac HTTP library that I used for that demo, the Web1 proxy creator, Myrtle again, and of course the AEC.
Very quickly, what year model was that? Do you know when that was released?
This is a 1998 PowerBook G3.
There are students in the room that are younger than that.
It's bound to happen eventually.
What's your oldest bootable Mac?
My oldest functioning Mac right now is a Mac Plus. It was made. They were made from 1986 onwards. Yeah, 86 through to 91, I think.
Amazing.
And they supported out of the box 1 megabyte of RAM, upgradable to 4. No inbuilt hard drive. You had to plug in your hard drive specially into a special port. This thing also has a SCSI port on it, but it's a slightly different shape. But that's a whole other story.
This has levers.
Oh yeah.
MacBooks don't have enough levers these days, I feel like. Look at this.
So Apple, in their wisdom, thought, what if someone wants to have 2 batteries, or wants to be able to swap the floppy drive out for a battery? And why just one side? Why not the other side as well?
Literally.
So you could have 2 batteries, or 1 battery in a CD drive, or 1 battery in a floppy drive, or do what I've done and have no batteries at all.
See what they took from us.
Swappable ports. They've all got these little covers and.
Any questions for Josh? Yes.
Did you have to take that laptop out for the security scan at the airport?
Yes.
This is not a technical question, but like, is that a Windows BIOS font using in your terminal?
Yes, it is. So this I've been using Ghosty, but the terminal here font here is IBM VGA. There's a old school DOS font pack you can get. This is specifically the aspect corrected one, because I don't know if you know much about the way DOS displayed text on the screen, but the screen is a 4:3 ratio, but the actual resolution of the pixels, if they were square pixels, would be slightly wider. So if you don't aspect correct it, it looks wrong to me. Like, I grew up with this font.
Yeah.
It's got to look like this. Thanks.
How problematic is back pressure in the agent? Like, do you get stalls with executables that can't write to the TTYs because you're not processing logs fast enough and all of that stuff?
That's pretty rare. I don't know of many issues where where the agent itself has been the problem. Particularly, usually it's the network's just not working for whatever reason, and so typically it'll try several times to upload logs because they're quite important to diagnose what's going on, but it will give up eventually. Typically there's some kind of data center networking fault or some other issue. The log processing on the client side is quite light. It does have to figure out where to insert timestamps and to do the secret redacting, but other than that, it's really just like copying data around.
Hey, what kind of testing strategies does Buildkite use to verify all the cases that you've got? I'd imagine that there's so many, given all the platforms and cases that you support.
Yeah, like I said, we don't have a huge zoo of platforms to test on, but we focus on, how do I put this? other than customer reported issues, because customers really care about their platform, and they'll often pester us quite a bit to make sure it works for them, which is really good. But we'll generally try and spin up something that mimics their environment to figure out what's going on in the case of a reported bug. But yeah, for the regular case where we've got sort of like business as usual, want a PR merged, want to make sure it works, want to run the unit tests and the integration tests. We've got the two Linux arches and Windows that we test the agent itself on. We've also got some machines that we spin up, like our Elastic CI stack gets deployed, torn down, again in like 3 different platforms as well. We have the mobile delivery cloud team have been doing a lot of testing with Macs themselves, because that's one of the things, big things is like supporting iOS devs. Yeah, I guess the main thing is good testing practices is a lot of things. It involves thinking up a lot of cases. It involves writing regression tests when you discover bugs. It involves being a bit more faithful with your with mocks and fake objects. So rather than mocking the client library, for instance, you're just testing that the code can call itself correctly. Actually, spin up a real server. Listen in on a port on the same host. Connect to it. Send some JSON to it. Get some JSON back. That shakes out a lot more problems than just mocking your client library. That kind of thing.
And last one.
Just how many megabytes of logs do you have to upload before one of your team members reaches out with questions, asking for a friend?
We have quota limits now, so if you shouldn't ever be able to hit that. But you know, some customers actually ask for lower limits because they don't want a job that lasts forever. They actually, and they don't want to have to wade through 100 gigabytes of logs to figure out what's going on with their job. So
there you go. Didn't I tell you that was going to be great? All right, big hand please for Josh.